Hi, welcome to the second video on Unit 6 triangles. So in this video we will discuss about similar figures. So in the first video of Unit 6 we discussed what is the difference between concurrent and similar. Concurrent means it will have same shape, same size. Concurrent means it will have same shape and same size, whereas similar means it will have same shape but not necessarily necessarily the same size. The shape has to be same, but the size can vary. So that is what we discussed. Okay. So here there are some examples like so. Let us look at these circles. So what we can able to observe is there is a bigger circle and there is a smaller circle. So these two circles are similar. It is not concurrent. Okay. So or you compare these two circles, this circle is little bit smaller when compared to this one, so these two are similar. It is not concurrent. Okay, so which can be called as concurrent? The circles with same radius can be called as concurrent. Okay, for example, the square with same side can be called as concurrent. An equilateral triangle with same side length can be called as concurrent. So these two squares, they are similar to each other. These two squares, they are similar to each other. They are not concurrent. They are similar. Even this equilateral triangle, these are similar figures. They are not concurrent. Okay. So what we can able to tell at the end is, okay, what we can able to tell is all concurrent figures are similar, but the similar figures need not be concurrent. So what is the meaning of this? So let us consider this one. So you consider this triangle and this triangle. These two triangles are similar, but it is not concurrent because the side is not same. And you take this inner triangle, this triangle and this triangle. These two triangles, it looks almost concurrent, right? The length and all, it is almost it seems to be equal. So I can call that one as both concurrent and also similar. It is both concurrent and also similar. So that is the meaning. All concurrent figures are similar. We can call all the concurrent figures as similar, but we cannot call all the similar figures as concurrent. It need not be concurrent. It can be concurrent or it cannot be concurrent. But we are not going to study anything about the concurrency in this unit. We are worried only about the similarity. Fine. How we can able to mathematically come up with something which is called as similar, because we need to use mathematics and we have to tell that these two triangles or objects or these two shapes are going to be similar. So how we are going to tell that one mathematically? Okay, so for example, we can able to see there are three Taj Mahals that are present. Okay, so these are not concurrent, we know it is similar. All these three are similar, we know that, because by seeing the figure itself we can come to the decision it is similar. Okay, fine. So how it is similar, how we are telling that it is similar? So there should be some way of representing that one with help of the mathematics. We have to express it that it is going to be similar. For example, it is like a rectangular figure. This Taj Mahal, it is looking like a rectangular figure. For example, say this angle, it is 90 degree here. Here also it is 90 degree. Here also it is 90 degree. So what I tell is, for similarity, the angle plays a major role. Okay. Okay. So now coming to this distance, let us assume this distance be L. So this distance seems to be a little bit uh, bigger. So it can be around say 1.5 L, and this can be say some two times of L. Okay. Similarly, let us take this as the breadth B. So this seems to be say 1.5 times B, and this seems to be say two times of B. So what we can able to observe is I have just given some values. So what we can able to tell is it is in the same ratio. It is in the same ratio. Take this L and this 1.5 L. So it is in the same ratio. So L by 1.5 L. So it is equal to take this B and this 1.5 B. B by 1.5 B. So it is 1 by 1.5 is equal to 1 by 1.5. So it is in the same ratio. That means the length and the breadth are expanding or compressing in the same ratio. Okay. So one is the angle plays a major role, and the second one is the proportionality of the sides. Okay, the proportionality of the sides. Proportionality, proportionality of sides. So the sides should be proportional. So if this side is, for example, this length is increasing from 1 to 1.5 L. This breadth is also increasing from 1 to 1.5 B. This length is increasing from 1 to 2L. The breadth is also increasing by 2B. So it is proportional. Okay. So if a figure has to be similar, then the angle plays a major role, and also the proportionality of the sides. It plays a major role. Okay. So we will understand more. We will understand more as we speak about this. We will understand more about this proportionality. So one more example is we used to go to the photograph shop and the studio and used to take photo, no. So the studio man will take only one photo, but what we can able to do, if we ask for a go and ask for a stand size photo, he will give it the same photo. He will just enlarge it and he used to give. We can get the passport size photo. Even we can get the postcard size photo also, or a bigger poster also. Okay, the same photo we can able to enlarge it or compress it, so all the photos are going to be similar. Okay, so it is not like in one photo I look in some other way, in the other photo I'm going to look in the other way. Okay, so with a single click all the photos are going to be same only, it is going to be similar. Even though the size are varying, the other things are going to be similar. The size also varies proportionally. Okay, so it varies proportionally. Fine. Fine. So the first point which we need to note down here is two polygons. Polygons mean it can be three-sided or four-sided or five-sided figures. Okay, two polygons of same sides, but it should have same side. For example, if it is here a triangle, both the things should be triangle. Both should be triangle. Okay. So since we are going to deal with the triangle, I'm just taking the triangle itself. So two polygons of same sides are similar if their corresponding angles are equal. The angles are going to should be equal. Okay, the angle should be equal. That means, for example, if this angle is say some x degrees, this also should be say x degrees. If this one is say some y degrees, this also should be like say y degrees. Okay? For example, if this is say x plus y degrees, for example, this also should be x plus y degrees. Though, so these are nothing but the corresponding angles. So this angle and this angle are going to be the corresponding angles. So it has to be same. It has to be equal, and their corresponding sides are in the same ratio. That is the proportion. It need not to be equal. For example, if this distance is say 2 centimeter, This need not be 2 centimeter. This can be 3 centimeter also. Okay. If this is 2 centimeter, if this also it is 2 centimeter, say this also has to be 3 centimeter. So it has to be proportional. If one side increases, the other side also increases proportionally. Okay, so that is the meaning of proportional. The ratio remains same. Okay, so one more example. So in this example, what we can able to observe is, so I think with this we can able to get a very good idea about the proportionality, about the similarity of the figures. So the angles has to be equal. The angles has to be same. If we talk about the angle, it has to be same. That is, it has to be equal. Because if there is a change in angle, the shape of the figure itself it is changing. Okay, the proportionality it is applicable only for the sides. The sides it need not to be same, it can be proportional, but the angles has to be same. So here it is 85 degree, here also it is 85. So 70 degrees 70, 105 105 and 100. So the angle it is equal, the angle are same and also it is equal. The next one is the sides it has to be proportional. So for if a figure has to be similar, both this criteria it has to satisfy. It has to satisfy the angle criteria and also the side criteria. Angle means all the angles should be same or equal, thus and the sides has to be proportional. These two criteria it has to satisfy. Then only we can tell that the two figures are similar. So here it has satisfied the angle criteria. Coming to the side, for example, AB is 1.5 and PQ is 3 centimeter. So there is a factor of 2. So 1.5 into 2 is 3 centimeter. Okay, or I can write it as 1.5 divided by 3. Okay, that is equal to 1 by 2. What I'm writing it is I'm just writing AB by PQ. Now coming to the other side, that is BC, that is 2.5 and here it is 5. So 2.5 divided by 5. Again I get 1 by 2. Coming to the third side, 2.4 and 4.8. So 2.4 divided by 4.8. I get 1 by 2 again. Coming to the last one, 2.1, 4.2. So 2.1 and 4.2. Again I get 1 by 2. So what we can able to observe here, we can able to observe that all the sides are proportional. All the sides are proportional. And hence these two figures are similar. These two figures are similar. Okay. So there is a note which we need to understand is, if one polygon is similar to the other polygon, okay, if that is the first polygon is it is similar to the second polygon, and the second polygon is similar to the first polygon, that is, let us assume say a polygon, say something like a triangle itself, the first triangle, the second triangle, and also have a third triangle. So if these two triangles are similar, and also if these two triangles are also similar, then it means that the first triangle and the third triangle is also similar. That is what the note tells. First triangle is similar to the second triangle, second triangle is similar to the third triangle, then the first triangle is similar to the third triangle also. Okay, fine. So now coming to this figure 6.6, whether these two figures are similar, let us try to explore it. Okay, so first, what, what is the condition? Angle condition, angle has to be same and equal, and the sides has to be proportional. These two are the conditions. Let us check whether these two conditions are satisfied. Okay, so we can see that angle A is equal to 90 degree, angle P is equal to 90 degree. D is 90 degree, S is 90 degree, C is 90 degree. All the angles are equal to 90 degree. Okay. So the angle criteria, it is satisfying the angle criteria. Good. Fine. Side. What is AB? AB is 3 centimeter and PQ is 3.5 centimeter. So it is 3 by 3.5. And coming to the next one, BC is 3 centimeter and QR is 3 centimeter. So it is 3 by 3. That is 1 by 1. Whereas here it is say 1 by say 1 point something. We will get 1.1. Okay. I think we will get 1.16 around, we get 1.16. Okay. So whether these two are proportional, it is same. Is it same? No, it is not same. So it is not accepting or satisfying the proportionality of the sides. So these two figures are not similar. Obviously, we know this is a square and this is a rectangle. It is not a square. So these two are not similar figures. So it has to satisfy both the things, angle and also the sides. Fine. Coming to the next one more. Let us see here. So whether these two figures are similar. So the first criteria is the angle criteria, and the second one is the side. Angle has to be equal, side has to be proportional. So angle means equality, side means proportionality. So please remember that angle means it is equal, side means it is proportional. These two things. So obviously we can see that this is a square and the angles are 90 degrees here, whereas these angles, it is not 90 degree. This is an acute angle which is less than 90. This is an obtuse angle which is greater than 90. So the angle criteria is not solving. It is not as satisfying the angle criteria. Whereas the side criteria seems to be okay. This seems to be okay. Okay. The sides are in the ratio 1 is to 2. 2.1 by 4.2. Okay. Here also 2.1, 4.2. Here also I have 2.1 and 4.2. Okay. All the sides are looks good and it is satisfying the side. It is proportional, whereas the angles are not equal. Hence, it is not similar. Both the criteria has to be satisfied. One is the angle, and the next one is the side. Angles has to be equal, and the sides has to be proportional. Fine. Okay. So in the next video, we will look at exercise 6.1, and we will try to solve these problems. Okay. Thank you.